Imagine you have a free party. You go and you see wonderful buffet for all the kind of food. Because you're not paying for anything, it's a free party for you. You go and try to eat a little bit of everything. Sometimes you take a lot of food on your plate, but you don't eat everything. Same thing happens in the cloud as well. If you're not charging back the cost to the customer, you will have cost leakage.
Is it the same approach you did use in Rippling where you talk about reducing the on-call alerts by 65%?
It has improved the happiness quotient in the team.
Okay.
Because like when people get paid less, they're like, okay, everything is good, right? I mean, last thing you want is like getting alerted at 2 o'clock in the night. And then you just have to acknowledge it, do nothing about it.
What has been the most catastrophic incident have you handled?
That's a fun part being in SRE world, right? You are going to be that firefighting guy.
The incidents which haunt us are the ones we are now prepared for.
Yes, indeed. Site reliability is a mindset, it is not a skill. People who don't know what is site reliability engineering TVs, these are all the guys you send to fix issues. You're going to deal with issues day in, day out. So you need to be having a troubleshooting mindset and not complain about things. And SREs make news when they break something. Right? So SRE is not for people with faint heart. Once SRE is always SRE.
Yeah.
I mean, if you look security and reliability, they are two faces of the same coin. Mm-hmm. These two aspects can make or break a company reputation.
Welcome to Zenduty Incidentally Reliable podcast. Today we are joined by Sudarshan Balakrishna, Director of Engineering, Infrastructure at Rippling. With over 15 years of experience spanning from traditional data centers to cloud-native architecture, Sudarshan has built SRE teams at companies like Rippling, Twilio, Oracle, and Walmart, consistently driving infrastructure, modernization, and operational excellence. Welcome, Sudarshan.
Thanks, Ankur. Excited to be here.
Yeah, same here. I'm excited to talk to you, someone who has worked in companies which I'm currently using some of the tools you are building. So you have had an impressive trajectory from technical sales engineer to director of Rippling right now. What are some pivotal moments which have shaped your career?
Yeah, that's a good question. So I've been lucky enough to start my career in the only subject that I liked in my engineering studies, which is Linux, Unix, and networking. That is something I was always passionate about. And wherein all of my friends were pursuing for companies like Infosys, traditional product development kind of a opportunity. I thought, what do I want to do in life? This is something I like, troubleshooting, fixing things. Then I started pursuing my career towards the Unix engineering, and then I started my career as a Solaris admin. Back then at Altisource, which is a financial firm. So I was dealing with a lot of big towers, servers, and data centers, racking, stacking things, installing machines, administrating them, all of that, right? Spent quite some number of years there, and then slowly started realizing how the industry is shifting. That is when the cloud started happening. Right?
This was in which year?
This was around 2010-ish, where a lot of things started transforming in the infrastructure space. Everybody was talking about AWS. What is this AWS? I had no idea. But then when I looked at what these guys are doing, okay, cloud is nothing but your infrastructure, APIs, and a lot of automation.
Yes.
Right? So I started thinking about where could the industry shift happen. Then I realized I think I need to upskill myself and try out these technologies, right? Slowly shifted towards cloud engineering. And then came the site reliability engineering. Oh, everybody was site reliability, DevOps. What is this all about, right? So having at the forefront of thought process and where the industry is shifting, trying to figure out new things and giving it a try is something I've done consistently. And I've been fortunate enough to get into those companies and work on those technologies.
Just for the audience, right? When you said you came across AWS, right? But you were already in networking, managing all those big data centers. Can you help understand the audience? Was there a big shift in learning? Because if in my understanding, you were already doing what AWS was offering, right? But in a much simpler way.
Yep.
So what did you learn from AWS when you started learning AWS? And what were you doing before?
Yep. For simplest analogy, I can explain like infrastructure is always 4 fundamental building blocks. You have a CPU, you have a memory that is RAM, you have a disk that is your IO, and then you have network, right? If you look at these building blocks and think of cloud, what is this cloud, right? These components are required for you to compute something. And if you run a traditional data center, for you to get a particular server, to install an application, to give it to the developer, finally developer deploys the code there, that goes into production. It takes months together. What the AWS or GCP or Microsoft Azure has done is they have built a nice infrastructure as a product offering, which basically gives you a nice UI. You can go there, log in, do a couple of clicks, provision a server, which usually takes some months together in a traditional world. That's what has changed the whole industry, right? Along with that, of course, you can talk to this cloud through APKs or SDKs and APIs and CLIs also. So the way you interact with the infrastructure, prehistoric of all the cloud world to what happens today, has significantly changed how you can go to market at very shorter time. That is the change that has come. And with respect to learning, fundamentals still remain the same. You just have to learn a little bit of coding like Python and all these infrastructure code tools like Chef to Ansible to Terraform. And then, of course, you have to be really good at Linux. That doesn't change, right? So this is what I had to learn. So yeah, it's been a journey and I'm still learning.
Okay, good to know. So you have established teams, cloud teams, as well as SRE teams across multiple companies from scratch, right? What are your guiding principle of building an effective SRE teams or a cloud team even before?
Yeah. So the way people who don't know what is site reliability engineering team is, these are all the guys you send to fix issues, right? Like there is a trouble, you need to send somebody to firefighter and make sure the fire it doesn't happen again. So the site reliability engineers are nobody but they are developers. Some of them are very inclined towards systems engineering or systems administration in terms of the passion and the skills they have around. Could be Linux, could be virtualization like VMware to Zen, and a good amount of coding to automate boring stuff, right? So these guys go look at how do you run production systems at scale, right? Which means you have to build the servers, you have to deploy the code, you have to have your CI/CD pipeline running there, and then make sure your application is always running reliably. And you are able to take care of uptime. If something goes wrong, you fix it. Make sure that doesn't happen. So that's what SRE folks do. And to build this or to be in this profession, the main thing you need to have is the mindset. Site reliability is a mindset. It is not a skill, right? Having said that, you're going to deal with issues day in, day out. So you need to be having a troubleshooting mindset and not complain about things. If you think, oh, I don't want to get into an incident, which is very tough to deal with, you really don't want to be in a SRE space. This is something you enjoy doing. It's like a puzzle, right? You solve a puzzle and you realize, wow, I learned something today, right? And how do you become really good at solving those puzzles gradually. So that's my 2 cents on what it takes to be an SRE and what are all the skills you need.
So, like you said, you actually worked in team. There should be SRE mentality. How do you identify those people who have those mindsets?
Yes.
Do you have certain guidelines which people can use, or maybe some pep talk which you use so that they can get motivated?
Yep, sure. I say to people, if you want to get to the bottom of it, you're finally going to think at the level of how does the memory works, how does the CPU scheduling happens, how does the network I/O happens, right? And these are fundamental, as I said, fundamental building blocks of things on which entire world runs today. If you are always interested in being a developer, let's say you are a developer in a company and you wonder, how do I improve my cache performance, right? How do I make sure I allocate a right size of disks to better my I/O for a database? You see, naturally, these are all the traits some SREs exhibit. I have had privilege to hire pure developers who had zero infra experience, but they had passion for these things. And it is just a matter of training them, reskilling them a little bit with the other side of things. So that is how you can transition from a developer to SRE. Some people start into system administration straight away, and then they are naturally into the SRE trade. Okay, so that's a mindset you need to have. If you are curious about things, if you are curious about fixing and breaking things, then you naturally know that these are all the kind of people you want to hire to this trade.
You have talked about going deep into cost saving, right? And That is a major factor with the new cloud coming in. We end up actually spinning up resources which are not being used at a full capacity or the right usage, right? I think cloud solution also comes with a problem, right? With the data center, you don't have to deal with. There are only hardware which you have already procured, which you have to use. But here you are actually paying for the compute by the hour, right? So you have achieved significant cost saving, hundreds of $1,000s across multiple companies. Can you take us through what has been a strategy,
Yep.
or maybe a playbook which they need to adopt, which they can use in day to day?
Yeah, sure. Let me give you a simple analogy to make it a little simpler. Imagine you have a free party. You go and you see wonderful buffet of all the kind of food. Because you're not paying for anything, it's a free party for you. You go and try to eat a little bit of everything. Sometimes you take a lot of food on your plate, but you don't eat everything and you waste. Same thing happens in the cloud as well. In all the company, no matter what cloud you run on, if you're not charging back the cost to the customer, you will have cost leakage. What I mean by that is people will provision larger fancy instances wherein if you look at their CPU or memory usage, it's not more than 10% or 20% of memory. But they want, because they think their application is going to guzzle a lot of workload, they end up provisioning big instances. And nobody pays attention to it until unless you get a very spiky bill. But having said that, cost efficiency is always right now kind of an afterthought. Okay, let's spin these VMs or Kubernetes cluster, let's see how much of bill we get, right? But what you need to do is, when you provision something, you need to really do a capacity math. What is the minimum amount I need and how do I scale when a traffic comes? Now with Kubernetes, you have all these horizontal pod HPAs, right, which can scale automatically when a traffic spike comes. So having said that, you figure out what is the bare minimum capacity you need, what is the max scale you can hit. Based on that, you provision. So that at the beginning itself, you're completely right-sizing your instance. Okay, let's say you don't do that. You have your number of instances running, and then you look into the insights of usage you get. You figure out how do you right-size these infrastructure so that your bill doesn't really go high. So that is one strategy of doing real cost cleanup, right? Having said that, there are a lot of different strategies. For example, there is a product called as Cloud Custodian, which is an open source tool. I implemented that at Twilio, wherein we were just seeing some resource were being, for example, we had EBS volumes, which was disconnected from ECS instances, but that was still there. It was not cleaned up, which was costing us a couple of thousands of dollars. We were just looking at how do we solve this problem? Will we write our own code, or is there anything in open source world? We downloaded a Cloud Custodian, implemented it. It has simple YAML file rules you can write. It started cleaning up things, okay. And then we were able to save a bunch of dollars, right? Similarly, if you look at, okay, there are multiple classes of CPUs available in AWS or in GCP or other cloud providers. The Intel and AMD's versus Graviton, which is by AWS, they don't have to pay royalty for buying these chips from AMD or Intel. So they have their own chips, and if you run your workload on those chips, Graviton, you are going to straight away save 20 to 30% of cost at the same performance, right? So that is something we tried, okay. And there are different tools, principles that are available. You can look at and what is best for your use case. You can instrument your cost savings accordingly.
So when you talk about cost saving and these strategies, these tools, right? Is it something you look into when it comes down to a requirement from the finance team that you need to start looking at? Or do you think it should be in the principles of a SRE team or cloud team to start looking into at initial stage also? I understand you talked about not thinking about VMs, spinning up multiple VMs initially when you're early into the product, because sometimes you also don't know what the capacity would be.
Yep.
But how soon they should start it?
Yep.
How soon they should start adopting it?
Yeah. This is what I call as cost debt, right? When you provision something without somebody pinching you that, hey, why this cost is, you're going to have the cost debt. Now, cost is one of the important SRE pillar, along with your reliability, monitoring, metrics. Cost is a very important metric you need to measure, which means you as a leader and every engineer should be responsible enough. How do they instrument anything they provision with respect to cost efficiency, right? Now, Terraform has a lot of modules that can upfront tell you how much of a cost this particular EC2 instance is going to have you, right? So if you instrument those correct provisioning mechanisms, you naturally know what it takes to run an application, right? If you have that instrumentation at the provisioning level, you're basically inserting a cost gate. After that, let's say you go into production, you are incurring some cost, then you work backwards, see where do you improve the efficiency, right? So it has to be built into your DNA of a SRE charter. Otherwise, you're always going to have somebody chasing you to bring down the cost, which is what happens in most of the companies. But now every company is kind of bringing cost as a discipline, and I think they are doing a pretty good job in most of the companies now.
And like you said, you have worked from an environment where you're working with a traditional data center, then you move to cloud, right? Have you worked on? It was a personal shift also. Initially, it was a personal shift. Have you worked in an environment where you have migrated from data centers to cloud, and then from cloud to Kubernetes?
Yep.
So, can you tell us those experiences and how did you adapt to that? What was your strategy?
Yeah, sure. I had a privilege of implementing OpenStack along with some of my US counterparts at Fidelity. So that time OpenStack was at the very peak of its, I would say, its product lifetime. The reason is that a lot of companies were still debating around the data security, should we go to cloud or not? Companies that had huge data centers, they were comfortable trying out something, the same capability that they can get in-house, which is, of course, your private cloud, right? OpenStack was at the forefront of it, and OpenStack is very complex, just like Kubernetes is, right? So I got a chance to implement OpenStack at Fidelity, and also at Walmart, I got a chance to work on OpenStack. Walmart has huge data centers, and they have their private cloud, similar to AWS web page. You have a page, you can go click a couple of things, and you can have your VM provision, and all of your application gets installed on top of it. Basically, a runbook is there, that runs automatically and does everything. Having said that, in all of these companies, you always have a challenge of clearing the tech debt by moving these existing workload from VM world to, or physical hardware to VMs. If you already have physical VM, it's already running, then you try to figure out where next. Usually it's always to, okay, let's say move into EC2 first, and then, okay, from EC2, what next? Kubernetes, right? So end of day, it's your application to code that you need to figure out all the dependencies, how do you declutter that and make a migration path possible. Yes, I've done that multiple times. And there is so much to learn there because you start building these fundamentally, it's a greenfield project most of the places. Get into the capacity, get into the dependency mapping, and hit into a lot of unknowns. So it's fun. It's usually multi-year projects.
How do you test your environment when you're actually doing these kind of setups, right?
Yeah.
Because there's always a risk of missing one or two very least priority services, right? Because those services are sometimes those services which you don't even touch for months.
Yep.
Those are not something which you actually push or deploy very often, right? Yeah. How do you make sure these, because most of the testing happens on the APIs and application level, right? Do you build some sort of infra testing also yourself to make sure you don't miss anything when you're doing these kind of migrations?
Yes. So there are different strategies based on different kind of migration that you do, right? But typically what you do is, every migration has a list. You make a list of all the application and dependencies and the criticality, right? Let's say you don't know some of the components that are unknowns to you, no documentation, no nothing. You go from least critical to most critical in the order of migration you want to do. To have this migration, first you build a parallel system, like a stage environment. You start deploying at a minute scale first and work backwards. If there is an issue, how do you fix this? And document it, most important, right? People do hurry-burry parallel migration, they end up having chaos and they don't know what dependency broke how. So you do that iteratively and capture all the learnings and try to see, is there an automation opportunity, right? Because when you introduce more human factors to this migration, you're going to have more complex issues. Let's say I did 5-6 migration. I know, okay, I create this Docker file, I deploy it over here, I enable this traffic, my application is live. So you figure out all these mechanisms and make sure, seamlessly you do as much as possible. You don't have to build a complete full-fledged automation because you're going to do migration one or twice in your probably 1 or 2 years in the company, right? So there's no one rule book to it, but it's situational, very situational. But what is important is having enough correctly built, at least in terms of capacity parity with the production that you're going to have, and correctly deploy it, test it, work backwards, capture the learnings, move forward. That's something that we have done. But having said that, every migration is a new one. It brings you new learning. So there is chaos, there is incident, but quickly recovering is the key to success.
Since you've handled the very big actually stacks, right? What kind of observability stacks have you worked on, and which one is your best, if there is any?
Yeah. I have worked pretty much on all observability stack. My favorite one is Grafana and Prometheus. The reason being they're open source. They also have an enterprise edition, but they're capturing market, and also they are giving you a lot of integrations. The integrations that is very limited or very platform agnostic, I would say. Of course, other tools are also amazingly impressive, like Datadog. And like you have Elk, and then you have Splunk, you have like bunch of other observability stack, right? Zenduty is also there, right? And Obsidian, and a lot of these tools. What is important is that the context switching an engineer has to go through when they are using your stack. That is important to me. And also at the same time, the cost of your product is very important, because you open your logs gate and then you send everything to your observability stack, you're going to get a huge bill. Right? So you need to have products that also educate the observability engineers that, hey, how to instrument your observability golden signals, like your metrics to logs to traces to profiling. Right? I think that is very important when you select a product.
Okay. So since when you talk about the huge number of logs which you are sending into observability stack, right? That's a different debate because on the cost side. But again, you end up actually consuming a lot of alerts, right? How do you... And I suppose that since your work experience, you must have actually gone through a journey where you have been actually bombarded with so many alerts, right? It actually causes alert fatigue, right?
Yep.
How do you deal with that? How do you actually, what has been your strategy on actually making sure you get the right alerts, or how do you filter out the main alerts?
So if you look at any alert family, right, logs has usually 3 type of logging category, right? You have your error, critical, warning, and info. What most people do is they ship everything to the product, and it's not even necessary most of the time, right? What do you do with info log on something like stage environment?
Yes.
You don't even need it. So only ship what is important. At the same time, make sure you don't miss anything very critical. That is one strategy, right? And then the other strategy is that you need to understand what that particular alert or log means to you. If it means nothing, nobody is even doing anything about these alerts, why are you even sending it? So you insert all this kind of filtering as much as possible when you bring log to the observability dashboard. That way you instrument correctly. And then most important expensive part of logging and metrics is indexing.
Okay.
The more you index, the more cost you pay. Right? So you need to know what to index. If you don't do that, then naturally you don't know how to instrument your observability stack correctly. Right? That's something I would say to people. And then at the same time, all the vendors, right? They won't natively give you the way to instrument discipline around cost. At the same time, alert fatigue, right? They say, okay, like I have all these fancy insights that will give you. Send everything. But are you really using those things? And most importantly, correlating the particular message back to what it means to your business or criticality of your application availability. So those are the things you need to really unbox and clearly have alerts that really make sense. If you don't have action on an alert, why do you even have it? Right? I mean, I ran a project at Walmart where we were getting 30,000 alerts per month.
Across, what was the size of the team?
The team was around 20-ish people.
Okay.
But like, they were getting 30,000 alerts. And of course, not everything was paged. Some were like on Slack, they will get it. Some were, they'll go into your X matters, they will look at it and figure out. Like, first thing I looked at is like, why are we even getting this? And then analyzed it, and then only went after top 10 noisy alerts. Then figured out some of them don't even make sense. Why do you even have it?
So how often do you do these exercises of identifying? Is this a recurring thing in your practices?
Wherever I went, this is the first project I always took.
Okay.
The reason being, I like operational excellence. The reason being is if you don't look from the operational excellence lens, you are going to miss big on where to start cleaning up things from, right? SREs gets frustrated because they get bombarded with noisy alerts, first thing. And also these alerts, it tells you a very good story of state of affairs of your infrastructure.
Yeah.
When you look into that, you really know where exactly are the pain points you need to go after, right? So first thing is you always get insights from these alerts, convert that to an action item, have clear projects as part of operational excellence, clean that up. And make sure you continue that rigor with a weekly review. So we do a weekly review of alerts. We see why are we getting these recurring alerts. If an on-call engineer has not solved these alerts, again we need to really pay attention to that.
Is it the same approach you did use where you talk about reducing the on-call alerts by 65%?
Yeah. We did that, and it has improved the happiness quotient in the team.
Okay.
Because like when people get paid less, they're like, okay, everything is good, right?
Okay.
And they
I
don't have
think
to
that is the
context
time SRE team would want to be called as SRE because they're not getting alerted, right?
Exactly, right? I mean, last thing you want is like getting alerted at 2 o'clock in the night.
Yes. If
And
you
then
slept at
you just
1:30.
have to acknowledge it, do nothing about it, right?
And that's more painful, I feel.
Yes.
Like you said, I think that is a major point. If you're not doing anything on that alert, that alert needs to go.
Yes. And with all these LLMs in the observability stack, right? Now, your observability LLMs can observe based on pattern of the alert. It can auto-remediate. There are workflows in all the products, like Datadog has Datadog workflows. Alert comes, it has a rule engine, it has a listener, it will listen to that. Based on the rule, it will route it to the automation, it will fix it automatically, right? But that's still a post-thought.
Since you talk about LLM and alerts, right? I can see that you have recently launched, you have worked on LLMs across observability stack. Have you used anything internally to help you better?
Yeah, I mean, we did a POC, okay? Like, so wherein like, based on pattern of alerts, we wanted to, you can just instrument the LLM, it starts observing, it will start recommending you.
Okay.
And then you just need to write a low code, no code kind of a workflow wherein it can automatically take care of that, okay? And that is something, it's a very generic approach in all the products nowadays. So I think that is something people can look at it. It helps you a lot. It makes your life better for sure. But again, they'll cost you. It will cost you.
Before LLM, right? Do you think in your previous experiences, you have built some sort of intelligence in your alerting, which you have used in previous companies? Can you talk about that?
Yes, I can talk about one interesting project. So there is a event-driven architecture open source product called as StackStorm. StackStorm basically has a bunch of listeners and integrations. It can listen to your incoming alert. Based on the alert, it will send that alert to a RabbitMQ. RabbitMQ, I think it has an engine. I forgot that engine name. Engine has basically a rulebook. Okay, it will look into it's a disk issue. Let me do some look at all the step files, clean it up, and then it will send a notification. It will wait for some time whether the alert will recur or not, and it will send a resolve notification to your observability stack automatically, so that you're getting an alert. Something happens in between, auto remediation, and then the alert goes away. You don't even get paged. You get paged only when all these things fail. That way, we were able to bring SRE fatigue significantly. That is something we were able to do at Walmart with a very quick POC.
So this auto remedial, which you talked about recently, right? So what percentage of alerts reduction has it costed?
We saved around, I think, 70 to 80% of alerts. We reduced that noise.
So now you're only focusing on remaining 20 to 30%, which actually needs
means
human intervention, right? Okay.
Yeah.
Okay. That's nice.
This predates all the LLM era.
Means I can understand we are going crazy about the LLMs which are there because of the capabilities they have. I think the capabilities are because it's easier to adopt. It's getting easier for anyone to learn. But AI and ML have been in the industry for a while, and a lot of big companies are already into it. They don't talk about it, but they use it silently.
Yes.
Okay. Yeah, it's nice to know that somebody actually talk about those AI and ML also. Right. With your experience across different technology stacks, right? What emerging technology or practices do you think that will have biggest impact on infrastructure reliability in the next few years?
Yeah. Everybody is using this term left shift or shift left, right? In infra world, it's always been reactive. That's why we have so many SREs, we have like huge infra platform teams. You build, you operate or run, and then you support.
Yes.
Now, what's happening is with all the fancy AI technologies emerging, the focus will be on improving the efficiency at the proactive layer, right? Or reactive layer, sorry. What it means is, how can I instrument efficiency at the beginning of the building pipeline itself, right? Let's say I'm provisioning a EKS cluster or Kubernetes cluster using Terraform. What are the checklist or quality gates I need to have with respect to cost, with respect to security, with respect to efficiency, right sizing, I will instrument all these checklists based on what type of workload I want to provision, and then provision that infrastructure, right? That way you are building right instrumentation, building blocks into your pipeline. And then your infrastructure provisioning happens, then you deploy your application, everything runs. Right now we are doing it at the very other end and working backwards to fix things at the beginning itself, right? So I will see a significant shift on that side because that will make the SREs or the engineers more efficient. They have more time to solve more interesting problems than solving some of the boring problems they do, like acknowledging an alert or trying to fix something where it has a never-ending solution.
I agree on that. How do you balance innovation and stability when managing infrastructure teams?
It's like a cap theorem, right? You can only achieve two at one point in time. But if you do it correctly, you can try to achieve parallelly as well, right? What I mean by that is stability is non-negotiable. I say reliability is non-negotiable. Imagine you have an internet of 500 Mbps and the internet is not reliable. It goes at the very moment of time you're doing a podcast, right? Why do you even need a 500 Mbps of internet? I would be happy if I get 100 Mbps, but it has a 99.999% of uptime, right? I mean, that 1.9 is a very fancy number. It will cost you exponentially to achieve that reliability, right? Having said that, you need to accept the business risk or business reliability that you are going to sign up. If I just need, let's say I'm a law firm. I'm not a bank, wherein my reliability is okay if I have 3 nines of a reliability. But I am like a phone pay. I need to have 5 nines reliability, right? So it's a very subjective matter. What does stability or reliability mean to you as a business? At the same time, innovation is very multidimensional, right? Reliability is one subset of that innovation. Now, every SRE engineer want to work on something very fancy, which is open in the market. Oh, something came, okay, let's just do it, right? You have to balance innovation with market fitment. Let's say I'm building something that has no use, but I'm learning something out of it, right? I don't think it makes sense because people just waste time innovating something that nobody is going to use. Wherein you figure out an opportunity in your business problem and put the same innovative mindset to solve that problem and quickly ship it. That will be the game changer. Okay, so you need to always be conscious of what you build, whether you have first customer or not. If you don't have first customer, then question yourself, why are you even building it?
After spending significant time in building and optimizing cloud infrastructure, right, what do you find the most challenging aspects of this infrastructure? But there could be that you don't find anything challenging now also, but if there is any.
The infrastructure, the most important thing is that you really need to know what you're building.
For what you are building.
Exactly, right? What I mean by that is, let's say take a SaaS company. There are product managers, there are platform engineering, there is development engineering or the people who write the code. Then at the very bottom layer is the infrastructure. Now, the communication from business to product managers to platform or the engineering, and then the infra has to be seamless. Right? Let's say, what products I'm going to launch next year? If I don't translate that to what it means to infrastructure, let's say, okay, we will sell our product in APAC region. Let's say, some company says that's an OKR. What it means to engineers to develop those products, they already have a code that is working in some other region. They'll localize that code to the new region or market. Then they will say to platform team, okay, we are going to consume these platform features. We want it in new region. Now the task is on the infra. Okay, we need to build a new region. What it takes to build a region in a given amount of time seamlessly. Make sure your product, your platform is hosted on that seamlessly and deployed and go to market live, right? So you need to get that translation very clear to infra layer. If that doesn't happen, then no matter how efficient infra engineers you have, you're not going to get your problem statement right. So product team talking to engineering teams, engineering team talking to platform and infra teams, that seamless communication is very important in any organization.
At what stage do you think that communication starts? Is it at the design level or the development level or even after testing?
I think it has to start much before. Right? Let's say any company has the sales kickoff. Right? Like sales guys will go and do a kickoff. We will achieve, let's say, n number of billions of revenue this year. Now product managers will say, okay, we will have to launch so many products to achieve those numbers. And then I will ask, what does it mean to me? Right? So it is that communication, because I need to speak the language of product engineer, they need to speak the language of what I understand, agree upon a common statement and get a sign off, and then start working backwards what it means to you. If you don't decompose this at the very requirement level, when you hit the execution level, you are too late. I see this problem in many companies where infra engineers are given a very short time. Hey, go build this.
I think it's the problem because they come to infra engineers when they have to get the application to staging.
Yes.
And once it goes to staging, they're like, oh, keep the production ready as well, right?
Yeah,
But
yeah.
even though there is still time from staging to production, I think that's the every painful thing which infra teams goes through, that they are not informed about these requirements early in hand. Like you said, it should be involved, right?
Yes, correct.
And sometimes there could be a budget issue also that they don't even have the budget to actually support that. They need to go for approvals and you have been early adopter of Bottlerocket OS, right, for EKS. Could you explain the advantages?
Yeah. So any Kubernetes cluster, it has a master plane, a control plane, which is a master node, and then it has worker nodes, which basically are big EC2 instances, right? Now these instances, the base OS is still a Linux operating system. You can have Ubuntu, you can have Amazon Linux, you can have any other Linux running. Now what happens is the base operating system that you run will be a couple of GBs when you install full-fledged. If you're running a couple of GB of operating system on a particular node, you are going to install so much of binaries, right? Which increases your threat surface. Because those are running binaries, they're running on exposing application on a particular port, and then a hacker can tap into that port. If it is open, then they can come in, they can like compromise your system. That is one aspect. Another aspect is when you do maintenance of these nodes, when these nodes reboot, it takes certain amount of time to come back. And then your Kubernetes agents run on it, and then your pods will come on top, right? So the reboot time increases significantly. The bigger the OS, more the reboot time. And then the cost, because this base OS also consumes your resources, it's going to definitely have more cost to it. These are all the compounding problems. If you look at operating system like Bottlerocket, again, that's a purposefully built for Kubernetes nodes. It's again a Linux, right? I think the current version is around 1.27, if I'm not wrong, or 1.23, something like that. So when you have something like Bottlerocket running, it has a very mean and lean operating system surface, which means it only gives you bare minimum libraries that you're supposed to have in an operating system, which naturally reduces your surface area of threat. And because it's lean operating system, the reboots are quick. You're running a very small operating system to consume the resources. So the cost is naturally going to be low. Most importantly, it offers you an immutable node, which means I can't go and change etc some config in a Bottlerocket easily, right? That means even a hacker gets into a system, he can't go and change anything. That's the reason it has been very popular. A lot of companies are evaluating this, adopting it based on their workload and the requirement. Yeah, so this is something we did at both the places, and it's a collective effort. I will not say just I did this, but this has been a practice now. I think this is what you call as inducing security when you provision an infrastructure, right? So Bottlerocket has been popular, and I think it's going to see more adoption as more people realize it.
Since you talk about security in the current age, right? But this is one piece which people should consider, even though we consider security by keeping everything under VPC, try to control the network, right? But what has been the reliability patterns change which you have seen from traditional data center to cloud and now Kubernetes? Can you talk about those?
I say reliability, as I said, reliability is a mindset, right? Reliability is non-negotiable. Same way, security is non-negotiable. If you look at some of the most infamous hacks like CrowdStrike to other things, it's all because somebody didn't pay attention to security. And security, they thought, okay, security is like vulnerability management, fixing patches, right? That's not anymore. I mean, if you look security and reliability, they are two faces of the same coin. If you don't have reliability, your brand name takes a hit. If you don't have security, your brand name goes for a toss. These two aspects can make or break a company reputation, right? Now, what do you do about this? Again, shift left is a mindset here. For example, we are developing a SaaS product, right? By the time you write code, Do you have 0-day vulnerability in your code, right? All of this is what you need to count in. Now there are so many plugins that will scan your code. As soon as you type anything, IDE, there are plugins in your VS Code that will tell you, hey, there is a security gaps here, don't use this pattern, right? So if you instrument all this from building the code, when you build your CI/CD, like in CI system itself, you run security checks as well, like Wiz, Snake, there are a bunch of things, right? You can run all of those. Make sure you're building a code that has no vulnerability. And also the Docker image you use today. Let's say I use just some Docker image, it will naturally have vulnerabilities by default. So you use the golden image that has zero vulnerability. I mean, we did a project at Twilio wherein we were remediating all the vulnerabilities at the image level itself. So that when the application is deployed, you have a image that is running zero vulnerability. So nobody is going to patch 1,000 or 2,000 list of vulnerabilities after you deployed something, right? So this is a proactive thought you need to have as good as like reliability. That's the reason both of them have to go in hand. You can insert so many security gates and do all these things, which will make your security posture very robust.
Can we talk about the fun part, the story part of our life, right? The war room stories, right?
Yep.
You must have come across, if you can share, keeping everything intact, right?
Yeah.
What has been the most catastrophic incident have you handled?
That's a fun part being in SRE world, right? You are going to be that firefighting guy always.
Well, you are the one who can actually tell stories.
Yeah,
you are the one who
exactly.
has stories.
Exactly.
Yeah.
So there was this incident in a company where I worked. Customer data was somehow deleted. And one of the executive from that company was on the line, and I was the incident manager.
Okay.
He was asking, get me your CEO on the call. I can't let this happen. I'm going to sue you guys. Right? So that's how important customer data is.
Yeah.
When I was trying to assure him, I have a guy who wrote this piece of code. Rest be assured, this data will be restored. Right? So being in that situation, and this incident ran for 120 hours.
Okay.
Across time. So we were doing handover, data was getting restored. Like we were showing that to the customer.
I suppose it was a huge data which was taking time to restore.
Yes,
also, right?
So a small bug that got introduced and deleted the data. Customer was on our neck asking for us to restore. We were able to get it. After that, customer really was super happy. They think like, wow. Though I gave you a tough time, but thank God, our data was not lost, right? So this is one of the examples. Similarly, sometimes there is a good day, sometimes there is a worst day. Right, you need to prepare for your worst day and plan your infrastructure to operate in that model.
What was the learning from that? Is it like you should not give everyone the permission to delete, or
don't send a human to do a machine's job? That's it's a slogan I stole. What I'm saying that is, all the incident that happens today, there is a human element to it. You can't blame human for that. A small comma mistake can wipe out a data, right?
Yeah.
So the best thing to avoid these incidents is instrument the right controls, automate as much as possible. Make sure you always have a plan B when something goes wrong, right? So if you handle these first principles of building, operating an infrastructure, I think everybody will be better off not firefighting things.
Like, I think in this incident also, the first principle was to make sure the backups are there.
Yes,
that's why you were able to
snapshot of multiple players, multiple snapshots and multi-regions. Those snapshots are stored so that you get the data back. Yeah, it's fun.
Nice. And tell us about a time when you had to make a difficult trade-off between stability and feature development.
Yeah. Unfortunately, like in all SaaS companies, feature requests take precedence and stability. Of course, everybody respects stability, right? But we don't get enough time to instrument those fundamental building blocks overhaul again and again, right? Let's say you build today something. If you're not thought through that correctly, you already inherited a tech debt. That's going to be a ticking time bomb 3 years down the line. And that's the reason you always need to pay back the tech debt by relooking at your architecture again. Right? Hey, what could possibly go wrong for a particular scale tomorrow that my application has to scale, right? If you are not doing that retrospection, one day there will be a disaster and you'll be at the receiving end, right? So having said that, I think revisiting and relooking at your architecture and looking at your alerts trying to correlate what are some of the breaking points that you discover is important. Some companies, like at Walmart, we used to do a lot of stress testing.
Okay.
So Walmart has this holiday season, like Big Billion Day in India or Amazon, right? They do a huge stress testing for making sure they identify breaking point much earlier and fix those. Till every program manager or engineering manager gives a sign off, we have battle tested our systems. It will scale for the traffic that's going to come on a holiday season. Nothing goes into like production or kind of a thing, right? So I think that is very important, right? You try to break your system and see what is your breaking point. For example, Netflix does this famous chaos monkey and all, right? They go plug some regions itself and to make sure Netflix is still operating. Right? I think that's being...
They have been, I think, the first one in publicly speaking about the chaos
monkey, chaos Kong, whatnot, right?
Yeah.
So those are very important for you to battle test your systems. It's like, like you're an army. Let's say you joined an army. You trained for entire life, but you never fought a war.
Yeah.
But you trained for that war that could happen, that couldn't happen. But when there is a war, all your skills will come into play, right? SRE life is like that. But of course, it's a different analogy I'm giving.
Yeah.
But we end up doing
how you train, right? I think chaos monkey or something like that, right? It actually gives you preparedness like a real war.
Exactly.
Which will actually help you in the real war situation.
Yes.
But most of the time, we also actually end up being in the side that the incident which haunt us are the ones we are now prepared for.
Yes, indeed.
Right?
And some of them are linemans. I call incident as linemans, right? Like somebody thought, this configuration is not used anywhere. Let me delete it. It doesn't have a blast radius, right? Then they do some changes. It's huge. Right now, that's where I say, you need to tier your systems. What is that small thing that can have a blast radius, which is like a nuke bomb, right? I mean, if you see some of the incident like YouTube not working, something going down, even I think, I'm not sure, all the streaming platform, they have this incident now and then, but how much of customer knows that is very important.
I think it has drastically reduced for the customer point of view. But I'm hoping that they are still handling those issues, right?
I just saw a LinkedIn post today wherein I think the Hotstar India-Pakistan match was around 50.3 crores.
Okay, the views,
Yeah, so imagine what it means for an SRE engineer.
Yeah.
Imagine those SRE amazing engineers, they build system to scale to that event. Right? I think that is what SRE engineers are. If somebody is watching favorite game uninterruptedly, you have to thank your SRE.
I think if any streaming platform has handled India-Pakistan match, they can handle anything. Any FIFA, everything they can handle, right?
So that's a God's work SREs do.
Has there been any experience where you have implemented a solution which you are not in favor of when you starting that, but it ended up being surprisingly successful for you?
Yeah. There is a lot of instances we had one incident. Okay, it's a very infamous incident, but actually it caused a lot of frustration to everybody. And the after effect of incident is not so good, right? But of course, we do blameless RCAs. And then my manager was very supportive. Hey, chill, relax. Well, look at what happened, right? And then figure out how do we make sure it never happens. We overhauled our reliability approach so much. After that, touchwood, we didn't have much incidents. Right?
Nice.
So there is a lot of grinding that team did to get to that level. After that, everybody was like, wow, this was worth. Though it was a hard lesson, but the dividends were really, really good.
Have you the migration which you have done? Can you share a challenging migration experience which you have done?
At Twilio, we were doing migration from ECS to EKS.
Okay.
And the timeline was around we had 1 year of a timeline where we thought, okay, 1 year should be good enough to migrate. And I had my team, some members, I always push them saying okay guys, here is the thing, right? Coding is the easy part. Figuring out the algorithm is the difficult part.
Yeah.
Right? So I told these guys, look, you're going to do this. You're going to do this like a cyclic manual process. Now, you may ask me, we're going to do it only once. Why should I automate this? I'm saying you don't have to automate everything. but whatever bare minimum components that you think is boring, insignificant, just automate it. It's okay to take a week time figuring out, doing 1 or 2 manual migrations, and then figuring out what can we write code around it. And then like people disagreed with me, but I pushed them hard. Then they figured out, then they wrote the automation, then they thanked me. It saved a lot. And because of that, we were able to decrease the migration time by 3 months. We were able to migrate it, I think around 7 months we migrated that.
I think people don't realize that by actually, it's like when you're trying to grasp anything, right? They tell you to actually write it down in graphs, right?
Yep.
Similarly, when you try automating them, it reduces the testing time.
Yes.
Right?
Exactly.
Because yes, you're preparing for the D-Day, but before that, the testing you're doing, if you're doing it manually, machines are something, right? They will do much faster than you. I know SREs would want to actually type. It's a song when you're actually typing in your Linux kernel, right? It's okay if you don't get to do that on every day, right?
We love black box.
Like some engineers have an habit of actually putting aliases to some of the requests,
commands,
right? Commands, right?
Yes.
But I think there are few people who still like writing the whole command themselves because it's a music to them. They're singers, right? When they're doing it, What advice would you give to engineers who are early in SRE or cloud infrastructure careers?
My only advice would be that technologies will evolve. You'll get new tools, new product. Don't try to be mastering one particular tool because that will become irrelevant in some years. Right? That's something people think, okay, if I become Kubernetes expert, my life is set. No, that's completely wrong. You need to get your fundamentals right. That goes back to read your operating system book like a Bible. There are good amount of systems performance book, like I think Brendan Gregg. One of my engineer in office ordered that particular book. It got shipped and I just looked at the index. Brendan Gregg, I think if I'm not getting the wrong name, Brendan Gregg is like the guru of performance engineering. He wrote books around Solaris. When I was starting as an engineer, we used to refer his PDFs and books. I was surprised that guy is still writing books for the new era of challenges and performance, right? So those building blocks, fundamentals never change. Of course, you need to learn new technologies like tools like infrastructure as a code. Today it's Terraform. A couple of years before, it was Puppet, which was very popular, and then Chef. Then came Ansible. Now it's Terraform. So the tools, mindset, problem-solving capabilities keep on evolving, right? But fundamentals don't change. So get your fundamentals right. Love what you do. If you don't like troubleshooting, if you're not curious about things, don't be in this trade. SRE is not for people with faint heart. You got to have curiosity, number one, passion, and if you are having complaining mindset, don't even think of becoming a SRE. Because you need to go and solve somebody's complaint. That is what you need to be in this trade.
You are the one who has to actually solve everyone's complaint,
right?
not the one who complains.
So these are all some of the DNA fundamentals you need to have.
And I think you rightly said that the SRE or the cloud infrastructure engineers are the ones, if you don't evolve, you will be left behind.
Yes.
If you have seen the other engineering verticals, right? They focus on their niche. They actually focus on their framework which they are working on. It's the SRE who have evolved over the last 20 years when you have seen from the data centers. Your designation may have changed, your playground may have changed, right? It's because you evolved with the technology, you're able to actually come this far.
Once SRE is always SRE.
I think it's just the abbreviation of how you pronounce it.
Exactly.
It's the same thing which you are doing, right? What's a common myth or misconception about SRE that you would like to debunk?
I mean, this is about like reward when it comes to like people think SREs get paid less or only developers get paid more. That is totally a myth. The reason, I mean, it's now available in Glassdoor and everywhere, right? You just go check a salary of an SRE in good companies like Google. They're making, if not more, but equal money or compensation, just like any other developer would do. Some places they are even paid more than the developers. Based on, like, for example, companies of like Netflix. Because like availability and reliability is everything for Netflix. Right? It's not that fancy button somebody's going to click on.
I think when you start putting reliability with customer happiness or sales number, it will come into picture.
People think, like SREs directly contribute to the revenue. And SREs make news when they break something. Right? So that is a myth. It's a very rewarding career. At the same time, it's also very learning-oriented career, provided you have the things that I talked about, like curiosity and firefighting mindset.
I think before we end, we wanted to actually start the new segment which we recently come across, the rapid fire technical questions. Kubernetes or OpenStack?
Kubernetes
Why?
is the future.
Okay. Your favorite infrastructure monitoring tool?
Datadog,
Most underrated DevOps or SRE skill?
Linux.
Okay. Do you go for manage EKS or your own native KAT?
My manage EKS.
Okay. ECS or EKS since you migrated?
EKS.
Okay. Why?
Because it has open source community support, right? It grows. ECS was Amazon's own proprietary
Okay. Microservice or monolith?
microservice. Though it's complex, it's fun.
Would you recommend going for microservice from the get-go if anyone is
Not
starting
necessarily. Start with a monorepo. Till you get till you go to market, start with a monorepo, right? But if you are going to expand significantly, launch new products, start doing microservice.
Okay. Multi-cloud or hybrid?
Hybrid.
Multi-region with multi-cloud or multi-region with same cloud?
Multi-region with multi-cloud. I don't want to be vendor locked into anything.
Okay, nice. It's a pleasure actually talking to you. There's a lot of things which we discuss. I think there will be more stories which we can discuss. For now, I think we can, with this constraint of time, we should end this.
Sure.
Thank you, Sudarshan, for being here.
Thanks, Ankur, for inviting me, and thanks for hearing me out. Some fun stories, and thanks for I learned so many things from you as well.
Yeah, thank you.
Thank you.